If you're a frequent programmer or just starting your journey, you've likely heard of recursion. But what does this actually mean? Recursion is a programming technique where a function repeatedly calls itself with a smaller instance of the same problem until it reaches a base case. Consider this very simple solution which calculates factorials for a given number. At the bottom here, you can see we call the function within itself, but we subtract 1 from the input each time. Hence we are calling the function with a smaller instance. This particular type of recursion is called tail recursion because the function calls itself as the last statement. And here we define what we call the base case, which will just return 1 whenever n equals 1. Now let's say we execute this function with an initial input of 5. The function call will be pushed to our computer's memory, specifically in the region known as the stack. It will begin to execute and then reach the last statement and call the function with an input of 4, which will then start executing until it calls the function with an input of 3, and then 2, and then 1, with each call being pushed to the stack. However, none of the functions return until n is equal to 1, as it is here, at this point we reach our base case and return 1. Thus the function call ends and gets popped off the stack. The return value then gets returned to the function call that had an input of 2, which resolves to 2, gets popped off the stack, and returns that value to the function call with an input of 3, which resolves to 6, and so forth until we get back to our initial function call with an input of 5 and we get our final answer. How cool is that? But there are some problems. Firstly, we need to make sure our base case is well defined. What would happen if we didn't have the base case in our factorial solution? Or what would happen if we submitted a number less than 1? In both cases, our function would call itself infinitely and use up so much memory that it would eventually throw a stack overflow error. On a similar note, imagine if our initial input was 10, or 50, or even 100. Apart from needing an intelligent solution to store and calculate such large numbers, this quickly increases the performance overhead due to a lot of function calls and also consumes a lot of memory, both of which aren't very efficient. So is recursion too inefficient to use? Well, not necessarily. Recursive solutions are often regarded as elegant and simple to implement, which can benefit the programmer, and if you know the space and time consumption of the solution will fall within an acceptable range, this may be the preferred approach. As a result, you may see recursion being used in divide and conquer algorithms or tree traversal algorithms. If performance and memory are an issue, some recursive solutions can be optimized through tail call optimization, also known as tail call elimination, which eliminates the need for a new stack frame to be pushed to memory every time the function calls itself. However, as the name implies, this is only applicable to tail recursive algorithms, and tail call optimization may not be supported by default by some programming languages or compilers. The final and probably most important takeaway is, all recursive algorithms can be implemented iteratively, that is, using loops. For example, here is an iterative solution to our factorial question earlier. Iterative solutions eliminate both the performance overhead and large memory consumption of repeated function calls that arise with recursion. But the drawback is, for more complex problems, iterative solutions are often regarded to be more difficult or messier to implement than their recursive counterparts. So what is my recommendation to you? Use recursion as a technique to break down problems that naturally lean towards a recursive solution, as this will often result in a clean and elegant algorithm. Then, depending on your performance needs, stick with the recursive solution or use it to help you develop a more efficient iterative solution. And that is all from me today. If you enjoyed this video, then feel free to check out some of my other videos and subscribe to stay in the loop.